Hi, and welcome to my supplemental lesson for 6.1 on simplifying algebraic expressions. Now, an expression, that really is something like this, 3x. That 3x means 3 times x. That operation is multiplication. And the 3, the number being multiplied by x, that we call that the coefficient. And the x is called the variable. Now that number, that represents a number that we might not know yet, and that number could change. It could change or it could vary, which is why we call it a variable. Okay, this is an algebraic expression. We have two terms here. Now this 3x, again that means 3 times x, that is known as a variable term because it has a variable attached to it. And that 1, that's a different term, that 1 is also called a constant. That 1 will not change. I can make that a 7 or a 5.5 or whatever. It's not going to change. So we call it constant. And that 1 could also be called a numeric term. Okay, so I have this expression here. And the expression has 3 times x plus 1 plus 4 times x plus 6. I'm going to use the commutative property to simplify this. And what it means to simplify is really I need to put things together that can be combined. I can take the 3x and I can combine it with the 4x. So I have the 3x here and I'll scribble this out. And the 4x, I'll add 4x and I'll scribble that out. So I've used these two, I kind of scribbled it out, a little bit. And then I have the plus 1 right here. Plus 1. Or I don't have to write plus 1. I could just call it 1. And plus 6. That's done right there. Okay. Now I'm going to simplify this expression. 3x plus 4x. That is 7x. All right, that's pretty easy. And 1 plus 6 is 7. So the simplified version of this is 7x plus 7. This is what it means to simplify the variable expression. So I had all this stuff. What does it mean to simplify? It means, well, I don't feel like doing all this stuff here. I don't want, if I know what x is, let's say x is 1, I'd have to multiply, or 5. Let's make it a little more difficult. 5. 3 times 5 plus, that was 1, plus 4 times 5 plus 6. I don't want to have to do all that. When I could just do this, 7 times 5 plus 7. So it's about kind of being lazy about it. Instead of doing all this stuff, this will get me the same answer. It's just simplified. I have to do fewer things. Next. Oh, actually, what I'd like to do is this one here. 2x minus 4 plus 5x minus 6. Okay, I'll take the 2x. Using the commutative property, I will remove that. Okay, and then the plus 5x. All right, plus 5x. Great. I've rewritten those. And I got that. Now, what is left over? I have the minus 4. Well, I'm going to have to write that as negative 4 right there. I know it was minus 4, but now I can see that it looks like a negative 4. And then I have this minus 6 right here, minus 6. Okay, let's put them together. 2x plus 5x is 7x. Write that 7 a little bit easier to see. And then negative 4 minus 6. We should know from our subtracting integers that is negative 10. Now we have 7x. To put it all together, we have 7x minus 10, and this is our simplified version of our long expression right here. So instead of doing all this stuff, you can just multiply 7 times whatever our variable is, minus 10, and you'll get the same answer. Okay, now we have these parentheses here, and that really works the same as this kind of problem. That addition, so we have parentheses, great. We have 2 sets of parentheses and the quantity of. So when you have something in parentheses, you read it as this. The quantity of negative 5x plus 7 plus the quantity of 2x minus 1. And this is how I'd put them together. First, I would have negative 5x plus 2x, and that addition sign is going to get used twice. So now I have 7, and I could get that rid of both of these here. So I have 7, that's positive 7, so I'll just write it as 7, plus negative 1, plus negative 1. And since it's plus negative 1, I'll put this in parentheses just to separate the operation from the sign. Now, I combine my like terms. Negative 5x plus 2x is negative 3x, and 7 plus negative 1 is positive 6. So when I write my final simplified expression, this is negative 3x plus 6. And that's what I got. So this, doing all this stuff, is the same as negative 3 times x plus 6. Okay. I have the next one here, which is 4x minus subtraction right there. So I'm going to write 4x, boom, that's gone, minus 3x. Okay, this is gone. Now, I originally had this as this. Let me rewrite this a little bit here. Sorry about that. That was minus 2, and that was minus 4. So when I scratch this out, I see that I have a negative 2. So I'll write negative 2. Minus, using that again, minus, and then I can see that I have negative 4. It was minus 4 before, but now that I've removed that and brought it down here, that's now looks like negative 4. Or I guess I could, negative 4. Minus right there, negative 4. Okay, I'll separate the operation of subtraction from the sign of the 4. Negative 2 minus negative 4. Positive peanut right there. Negative 2 plus 4 is 2. And 4x minus 3x, that is 1x. But if I have 1x, that's the same thing as just saying I have x. If I put this together, I have x plus 2. X plus 2, and that is my simplified expression from my original expression. Okay, next we have the distributive property. And I'd like to clean this up a little bit. Hold on. So in this, using the distributive property to simplify the expression, this means 2 times, so right there is the operation. If there's nothing there, that means you multiply. Just like up here, this meant 3 times x. There's no operation shown right there. This means that. Right down here, this means 2 times the quantity of, remember, in parentheses, the quantity of x plus 1. And so we use the distributive property. We distribute the 2 to each item inside the parentheses. And when we distribute, we are multiplying 2 times x, that is written as 2x, plus 2 times 1, and 2 times 1 is 2. So that's really it. We distribute, going this way from here to here, that's distributing. I'll write DIST for distributing because I already have distributive right there. But if I am given this and I'm asked to go from here to here, that is called factoring. So I would have to factor out the 2. I divide each of these by 2. 2x divided by 2 is 2. And 2 divided by 2 is, 2x divided by 2 is x. And 2 divided by 2 is 1. So when you divide both of these by 2, you get that. But we are usually going to be distributing, so we're going to be pretty much going that way. And I have this one here too. Let me clean this up. And I have this expression, 3 times the quantity of x minus 4 plus 7. So this is 3 times all this stuff. So 3 times x and 3 times 4. 3 times x, well, we should know that's written as 3x. Minus 3 times 4 is 12. And then I have plus 7. Okay, now I'm supposed to combine my like terms. So all the variable terms. Okay, I only have one variable term, that is 3x. And that is gone. That's already rewritten down here. And then now I have negative 12. See, it was minus 12, but now we can see it's negative 12 plus 7. And negative 12 plus 7, that is negative 5. So I'll just write that as minus 5. And so this 3 times x minus 5, you will get the same answer as 3 times the quantity x minus 4 plus 7. And let me show you real quick. What you'd have, let's say x is equal to 3. Okay, if x were 3, then I have 3 times this. I'll just write this whole thing, x minus 4 plus 7. So if x were 3 now, I can say, okay, that's 3. I put 3 in for x, 3 minus 4 plus 7. 3 minus 4 is negative 1 plus 7. Now, see, I did 3 minus 4 is negative 1. And then I'm using the order of operations at this point to keep getting down to a single number. 3 times negative 1, that is negative 3 plus 7. And when I put that together, I get negative 3 plus 7. That is 4. Okay, so I did all that work here, but I'm saying it's the same thing as these two are connected. They give you the same answer. So if I have 3x minus 5, but I said that x was equal to 3 here. I substituted 3. So I'll substitute 3 here, and I should get the same answer as 4. So 3 times 3 minus 5. See, I substituted right here. And 3 times 3, that is 9 minus 5. And 9 minus 5 is 4. So see, this expression is linked to this expression. If I substitute any number for x and I use the order of operations, I would get the exact same number as I just showed you with when I substitute 3 for x right there. It could be any number. It could be 50,000, whatever. You'll still get the same answer. Okay, so that's what you got to know about simplifying algebraic expressions. Thank you for watching.